Welcome back to Math for Technology. We're moving on in Chapter 5 with the trigonometry. We're going to be working still with just right triangles, but we're not working with them necessarily in standard position. So our first one that we're going to work with here, I have a right triangle drawn. It gives us angle A at 55 degrees. It tells us that our side B is 7.92, and it says to solve the right triangle. So solving a triangle means find out anything that is unknown. Well, I don't know what side C is, I don't know what side A is, and I don't know what angle B is, so I need to find those three. I know angle C because that's my right angle. First thing I'm going to go ahead and do is find angle B. We know triangles add up to 180 degrees. We know the right angle is 90 of it, therefore angles A and B must also add up to 90 to take care of the other 90. So to find angle B, I'm simply going to do 90 minus 55, and that will give me 35 degrees. So I know what angle B is. That leaves me needing to know what angle A or angle C is. Before I do that, I'm literally going to write down the opposite, the adjacent, and the hypotenuse so I know where those sides are. If I'm standing here at theta, this is what I know. Little a, because it's across the triangle, that's my opposite. Next to me is my adjacent, and across from the right angle is always the hypotenuse. If this is the angle I'm working with, I need to know the opposite, I know the adjacent. So I'm thinking, okay, which one of my trig functions uses opposite and adjacent? My first thought is tangent. So let's see what I know. Tangent of 55 degrees equals, tangent is opposite over adjacent. I don't know opposite, so I write an A. I do know adjacent, that's 7.92. So I actually only have one variable. If I have one variable, I can solve the equation. So I'm thinking back to my algebra. I am currently dividing by 7.92, so I'm going to multiply by it to eliminate it. If I do it on the right, I have to come over here and do it on the left. So hopefully you have a calculator either online or in front of you that you can plug in. Make sure that you are in degrees. Somewhere it has to say like DEG, so you know you're in degrees. If you can't figure it out, make sure you look it up online or use the manual that may have came with it. So I'm going to plug in 7.92 times tangent of 55 degrees, and it gives me A is approximately 11.3. Now you might ask yourself, how do I know when to stop? It's based on what is given to you. So if I look here at side B, I have 7.92, that's three numbers. So any other sides that I find should have three numbers in them, and then use your rounding rules. Now that I know what side A is, to find side C, if I have 2 out of 3 sides of a right triangle, I can simply go back and use the Pythagorean theorem. So I'm going to do that. My Pythagorean theorem, remember, is a squared plus b squared equals c squared. A is 11.3, b is 7.92, and I'm solving for c. So 11.3 squared plus 7.92 squared, and then I'm going to square root that. So my C is approximately 13.8. I know what C is, I know what big B is, and I know what little a is, so I know everything about this. I have solved the right triangle. In this first case that we had, we knew one angle and we knew one side. Sometimes, as in example 3, I only have sides and I have no angles. Now before I can do example 3, I have to know how to plug some stuff into my calculator. If I am looking for angles, I do what is called the inverse sine to find those. So when I go to solve A, which is sine of angle A equals 0.896, this is the ratio. To find the sine, I don't actually use sine itself, I do the inverse of sine. So this little exponent of -1 tells the calculator that I'm looking for the angle instead of looking for the ratio. So sine of -1 is 0.896. So hopefully you've found that button. For sometimes you have to hit the second button before you hit sine. Sometimes it's another way to get to it. So the inverse sine of 0.896, oh, I'm in degrees, so I have to switch that, or I'm in radians, so I'm going to need to switch that, is approximately 63.6 degrees. Okay? So when I'm looking for angle B, I'm going to do the inverse cosine, 0.548. Inverse cosine, 0.548. $56.8 approximately. For angle C, I'm going to do the inverse tangent, 5.324. This one I'm going to go ahead and do in radians just so you can see how that works. It doesn't matter, it's all based on what your calculator is in. So inverse tangent of 5.324. In radians, that's going to be 1.39. I'll go ahead and write rad so you realize I'm in radians. Now, depending on your calculator, some have the cosecant button and some don't. My calculator does, so I can just push the inverse of cosecant of 9.026. If your calculator does not have a cosecant button, then you have to think about who is cosecant the reciprocal of. It is the reciprocal of sine, so you would end up doing sine to find your angle, and then because it's the reciprocal, when you plug it in, you have to flip this over, and there's an invisible 1 there, so flip that over and it'd be 1 divided by 9.026. So if you have cosecant, do the one on the left. If you don't, do the sine or the one on the right. So that, and again I'm going to do it in radians. So that's approximately 0.111 radians. If it doesn't tell you how to write your angles, you can do it in either degrees or radians. I don't really care. If it tells you specifically, just make sure you answer it appropriately. Okay, now that we know how to find an angle, we're going to come down here to example 3. We are solving the right triangle. This time we're given A and C. Now, right now I really don't know where I'm at, but it's wanting me to know, and it really doesn't matter, you can choose wherever you want to be. A lot of people find it easiest if they just always stand at A or always use A as their theta. And I'll just do that. So now I'm going to label before I try anything. Little b is adjacent, little a is opposite, and C is the hypotenuse. Now I can't find any angles, so I'm going to think about which numbers do I know and how can I use them. I have the opposite and I have the hypotenuse. Opposite and hypotenuse are, you have to think about which trig function that is, and that is sine. So I'm going to write sine of A, because I labeled everything off of angle A, is opposite, which is 23.5, divided by hypotenuse, which is 42.7. Now I'm looking for the angle, so when I plug it into my calculator, I'm going to do inverse sine, and I can just tell it 23.5 divided by 42.7. It'll do all the math for me. So inverse sine of 23.5 divided by 42.7, and most of you probably want that in degrees. I think people are just more comfortable that way. So if I have that in degrees, it's approximately 33.4. degrees. So now I know angle A. If I know angle A, I can find angle B. Angle B is 90 minus 33.4. Remember, it's 90 because C has taken 90 of the 180 already. So that would be 0.6, so that's 4, so that's 6, so that's 4, and that's 5. So angle B would be 56.6. Now the only thing I don't know is little b, or side b. So again, I have 2 out of 3 sides of a right triangle. I can simply do the Pythagorean theorem. So I don't necessarily have to do trig. I could if I wanted to, but I don't need to. I'm going to do 23.5 squared plus b squared equals 42.7 squared. Make sure you square root it. And so little b is approximately 35.7, and that's really horrible, so I'm going to erase that real quick. 35.7. So I had 3 things that I didn't know, and I found all 3. As I look at example 4, really the only difference in this problem is that the angle is given to me in radians. Since it is, I need to work in radians. Either change your calculator to radians, or you can convert it to degrees, but then you have to give your answer in radians, so you'd have to convert it again. So I find it easier just to put your calculator in radians. So this time, since this is the given, I'm going to make this be my theta, and I'm going to label accordingly. A is actually next to it, so this is my adjacent. B is across the triangle, so that's my opposite. And C is always the hypotenuse. Well, go ahead, we can find angle A first. In radians, 90 degrees is pi over 2. So what I can do is, to find angle A, I can do pi over 2 minus 0.62. Then I'll just use my calculator. So pi divided by 2 minus 0.62. My calculator lets me know it is approximately 0.95. So I now know angle A. So 1 down, 2 to go. I tend to find things in alphabetical order, but it truly doesn't matter. If I have opposite and adjacent, because I know the adjacent, I'm looking for the opposite, that is tangent. So I'm going to try and set up my trig function. Tangent of 0.62, again I'm making sure my calculator's in radians. It's opposite over adjacent. I love the way my letters are on the top. Makes things easier because I can just then multiply by 23.85 in this case. Multiply by 23.85. They cancel on the right. And on the left I get 23.85 times the tangent of 0.62. And so I find out that little b is 17 point. Now A is 1, 2, 3, 4 numbers, so on 17 I'm going to go 4 numbers. 17.03. So now I know little b. All I have left is little c. Back to the Pythagorean theorem. 23.85 squared plus 17.03 squared is c squared. 5 squared. Make sure we square root it. And I get that c is approximately 29.30. Now you might ask yourself, why did she put the 0 there? It's so that I hold the positions showing that I did go 4 numbers. Okay, I know everything that's missing, so I'm done with that one. So we've done some examples in radians, we've done some in degrees, we've done some where we either know 2 sides, we know 1 side, 1 angle. So let's do some situations. I have a private plane that flies 1.3 hours at 110 miles per hour on a bearing of 40 degrees. Then it turns and continues another 1.5 hours at the same speed, but on a bearing of 130. At the end of this time, how far is the plane from its starting point? Okay, so I'm actually going to go ahead and put a coordinate system back in here since they're giving these degrees and the bearings. Okay, so I'm going to not necessarily go to true north. If that bothers you, you're welcome to go to true north. So the first thing I'm going to do is I want to go 40 degrees. So I'm thinking of the x-axis as 0. So 40 degrees would be going this direction. And this would be 40. Okay? Now if it's traveling for 1.3 hours at 110 hours, I'm going to multiply those. 1.3 times 110 gives me a distance of it going 143 miles. Now, at the end of that, so here, we're now going to turn, and it's going to travel at a bearing of 130 degrees. So I'm going to make myself a little mini thing here. I'm going to think, okay, if I keep this at 0, and I'm traveling 130, I'm going in this direction now, and I'm going at a bearing of 130 degrees. And I'm going for 1.5 hours at 110, so I'm going to multiply those. 1.5 times 110 says that I've traveled for 165 miles. And then the question says, at the end of this time, so when I get to the end of this 165 miles, how far am I from the original starting point? So you might say, well, I don't have a right angle. Let's see what we do have. So I know this is 40, so I know this is 50, and I'm drawing an invisible line if I were to extend this. And because I know that in chapter 3, parallel lines cut by a transversal, if that's 40, then this is 40. And if that's 130, then I can do that's 130, 180 minus 130 is 50. Now look what's been created. 50 plus 40 is a 90. So I really do have a 90-degree angle right there. So I'm going to go ahead and pull that off just so I can see what I'm looking for. I'm looking for this. We just showed that that is a 90. This was 165 miles. This was 143 miles. And they're saying at the end of the trip, how far is the plane? I'm looking for this. And at what bearing is it from the starting point? So here's the starting point right here, and it wants to know what's the bearing. So we want to know, if I were to draw in the x-axis, what would this angle be? Well, let's start with finding x first. I have 2 out of 3 sides on a right triangle, so back to the Pythagorean theorem. You might be getting sick of it, but it is so helpful when you have right triangles. Makes our life super easy. 165 squared plus 143 squared. Square rooting that. So I know that I've traveled 218 miles approximately. It's a little bit more. Okay, so that's this guy. Now the question I have to figure out is, what is it from the original to here? Now I already know that this piece here is 40 degrees because it was 40 degrees originally. If I can find this one, then I can just add it to that one. Well, if I'm looking for this, we'll say it's A. This would be the opposite. This would be the adjacent. Opposite and adjacent is tangent. So I'm looking for angle A, and I know the relationship for tangent is opposite over adjacent. So if I'm looking for the angle, I actually do the inverse tangent. I can tell my calculator to go ahead and divide those. So inverse tangent of 165 divided by 143. Oh, I'm in radians. See, got to be careful of that. So I got to get it converted real quick. So I end up with 49 degrees approximately. So the entire bearing then, 40 plus 49, so it's at an 89 degree bearing. I obviously didn't draw it right because it's almost a 90 degrees. But that's how I could figure it out. Pictures are very, very helpful. So try and always draw a situation. Okay, this situation. As a balloon passes between 2 points, A and B, 2 miles apart, the angles of elevation on the balloon at these points are 21 degrees and 41 degrees respectively. Okay, so let's put our 2 points in here. I have point A, and I have point B, and I have a balloon. Whatever your balloon looks like, that's a pretty pathetic balloon. It says they are at angles 27 and 41. So this is 27, this is 41. Find the altitude of the balloon. So I'm looking for this distance. Well, if I draw that back down, I have created a right angle. Now it says that they are 2 miles apart. So this from here to here is 2 miles. I was just looking at this and I just realized that, so if we think about what we know, let's do that real quick. So that's 90 and that's 27. I know this is 63 degrees. That's 41 and that's 90. I know this is 49 degrees. So besides these right angles that I've created, I don't know anything else. And because these are not equal, I can't split this 2 miles in half. So I don't have any of these sides, and I cannot solve these if I don't have any sides. So this one is going to have to be tabled until I give you a different tool. So we'll just table that one for now. That was my mistake. Okay, let's go down to number 7. If you've decided to go camping with some friends, while out on a hike you reach the top of a ridge and look down at the trail behind you. In the distance you can see your camp. You are thinking about how far you have traveled and wonder if there's a way to determine it. By using a small device called a clinometer, you are able to measure the angle between your horizontal line of sight and the camp as 37 degrees. And you know that the hill you just hiked up has a height of 300 meters. Find out how far away your camp is using this information. Assume that that the trail you hiked is slanted like the side of a triangle. So they're asking you to find this. Now if I know this is 37, what I really have created here is a 90-degree angle. So I can do 90 minus 37, which would give me 63. So I do know this angle that's inside of this triangle that I've created here at the bottom, and this is also 90. Based on this angle, if this is my theta, this would be my adjacent. Over here, my unknown is my opposite. And x, as always, because it's across from the right angle, is my hypotenuse. So with my trig functions, I have to think about who uses adjacent and hypotenuse, since I need hypotenuse. Adjacent and hypotenuse is cosine. So let's think about cosine here. Cosine of 63 degrees is, cosine is adjacent over hypotenuse. Now this one's different. Before I've always had my variable on the top. I don't have that in this case. So really what I'm going to need to do is think about reciprocals. Cosine, if I do the reciprocal of this, cosine's reciprocal is secant. I keep the same angle. I flip this upside down. It's x over 300. Now my variable's on the top, so I can do the one quick step, multiply by 300, multiply by 300 to get rid of that. So I'm going to do 300 times secant of 63 degrees. And it gave it as a big fraction, so once I get that fixed, I know that he has traveled, or I have traveled, approximately 661 miles? No way. Meters, definitely. It's like, there's no way we've traveled 661 miles. That's just not reasonable. Okay, now you might be asking yourself, if I have a calculator that doesn't have secant, how do I plug this in? So, remember you'll be doing cosine because that's the reciprocal. So what you're going to do is you're going to plug in 300 times 1 divided by cosine of 63 degrees. That way you're really doing the reciprocal of that. Okay? And you should still get the 661. With that, we're at the end of this section. That tabled one we'll end up coming back to later when I give you another tool. I'll remember that that's there. And with that, that's the end of 5.3, and I'll be moving on to 5.4. Have a good day.